start recording. Now I'm all set up. Sorry guys, I'm a bit slow today or the past days. So hi and welcome to the SUSE QE Tools workshop. Today the topic of the 6th of March 2026 is that I would like to present you the success we had with Saga about reliable and resilient QA infrastructure management. The Saga originally I created 3 years ago, and it was like a collection of basically daily work, but also then based on the daily work and related to that, always trying to come up with some improvements for the future while we manage our QE infrastructure within SUSE. We have in total, we had 166 closed tickets, so this is really a big Saga. It didn't have any proper, not any kind of elaborate motivation. It's more like after we had a previous Saga, which was called Up to Date and Current QA Setup in SUSE, like refreshing a lot of the setup that we inherited and a lot of legacy. Now we can have more ideas how to improve QA infrastructure management. And improve is a, word here where maybe that's a bit going too far because, as I said, a lot of daily operations included, but again, always trying to find some improvements for the future. So from the 166 tickets, if we group that by different parameters, so for example, let me group by priority and project is there. So we had 96 tickets in OpenQA infrastructure itself, 31 tickets in the OpenQA project, and on the second page we see 27 SUSE internal tickets and one bigger collaboration organizational task. So provide additional 3 worker Power 8 machines could also be in one of the other sections, but what that means is that basically the request came from possibly QE project managers to provide more O3 worker machines in that domain. And QA public is also like our most generic section. So, and what we can see here is, for example, a lot of organizational tasks, because what we did in the scope of this Saga is to have actually have a split of the former QE Tools squad into 2, which is now the QE Dev and QE Infra. And this Saga was the bundling group where we would accommodate this organizational work, including set up processes, make all those decisions within the team, outside the team, with the stakeholders, update our process definitions like the wiki page, which would describe it, but also some things like related to split backlog queries. So I can show you something for that. And I know that the team members know that from daily work, because every day we look at this page. So we have this backlog status, and this guides our work in the teams. We have combined backlog dev plus infra, because I'm product owner for both. So I'm also interested in the overarching scope. But then for the individual squads, what is more interesting is for QE dev, the dev backlog, and for infra, the infra backlog. You can see that some queries are split, but for example, our SLAs and the SLOs that we have defined, they are joined. Of course, there's always a possibility to split this further by scope, and we do it gradually, step by step, where we see that it brings us a benefit, but so far it's working out to do that in a rather conservative fashion, and it's working out fine. As you can see, right now the backlog status is green. It usually happens, let's say, every day 1 alert, maybe 2. that pop up, for example, if there's a new untriage ticket, we would see it on this dashboard. We also see it in notifications, like we would receive a chat message about new any of those alerts triggering, and then either I react mostly on the untriage ticket, or somebody from the team can react and say like, yeah, oops, my ticket is like taking a bit longer than expected, and react accordingly. Yeah, Heiko?
What is the difference between SLO and SLA?
Ah, nice that you ask. So the SLA is the agreement that we want to promise to our stakeholders, for example, you, okay? And this is all defined on our wiki page. So if we go here, then it says
Mm-hmm.
service level agreements, and it's basically like order of magnitude of reaction of time. Okay, so if there's an immediate ticket, then you can expect that within one day we at least pick up the tickets. We might not be able to resolve it, but within one day you can expect us to pick up a ticket, provide reasonable updates based on the priority, where the first goal is urgency removal. An example would be OpenQA SUSE QE down. Okay, this is impacting more than 100 people within SUSE. So within one day, you can expect that there's some kind of reaction. If it is within our power, of course, we would apply some workarounds to bring it back, and maybe reduce the ticket to urgent to say, okay, we have a slight performance degradation, but it kind of works. And then the next level would be urgent. So within 1 week, regardless if it's a new urgent ticket or a former ticket that changed its priority to urgent, within 1 week we would react, and then high and normal accordingly. The
I see.
SLOs, those are the objectives that we have internally in the team, and we have more strict objectives than what we give as the promise to you. It's this kind of so this is the more hard guarantee, but because it's more strict, the levels are less demanding, right?
Yeah,
Um,
sure. Makes a lot of sense. I think you don't have to dive too deep
yeah.
into that for my benefit. So it's
Okay.
basically agreement versus objective, and surely, I mean, objectives are more strict than agreements. Otherwise, you couldn't meet the agreement.
Exactly right.
Yeah.
And those, I mean, none of those had been demanded externally, and it's really all based on a proposal that we gave as a team, or that I gave to you and other stakeholders, to say like, look, this is what you should be able to expect from us. And I think it helps a lot in a mutual communication, to maybe we cannot do something, but at least we can be openly communicate, and make sure that everyone understands what is possible and what is not possible.
Thank you.
Okay. Yeah, so and also related to backlog, for example, reconsider higher work in progress limit. You might know in Kanban, one important concept is a work in progress limit, because what matters in the end for stakeholders and users is the value that is delivered, and not how busy we are and how many things we do. So the important point is in the end to finish work. And finishing work can be supported by making sure that there is a limit on the former steps, to say you shouldn't start a lot of things and never finish, but really pull from the end. And if we are limited in, we cannot pick up one more task because that would push us over the work in progress limit, then our focus shifts on actually making sure that we help each other to deliver things. But this is also related to external dependencies. In particular for QE Infra, one of the important impacting factors is, for example, SUSE IT. Yeah, so there's a lot of, now more than in before, infrastructure where we don't even have physical access to, like we have data centers which are managed by SUSE IT, ITP in particular, and we rely on that infrastructure. We can do a lot with remote administration, but ultimately in the end somebody needs to physically attend machines sometimes, or set up the central firewall. And it was already leading to problems like years ago, and this is an ongoing challenge, the high amount of external dependencies we have in this squad. So this is why you also see tickets like improved collaboration with engineering infra, which is meanwhile ITPE. And we could improve, but as I said, it's an ongoing challenge. Let me quickly take a look here if there's anything noteworthy from internal, like yeah, just examples of OpenCase SUSE specifics uh, can or should go in this category because it's like SUSE internal. There was an SUSE IT restructuring, and we need to understand the structure so that we know which are the right people to talk to, what can we expect from each, so that a request or a ticket doesn't go to the wrong team, who then everything is stalled for some months because nobody knows what to do. Because there can be sometimes outages, we will react accordingly. And if something like a bigger incident which is impacting users happens, let's say OpenCase SUSE would be down for longer and people would realize and be impacted by that, that usually means we need to do more than just recover it. And really, we do the effort to go into lessons learned processes and collect the experience, like what happened, why did this happen, what can we do as improvements. So usually, as a consequence of a bigger outage, we have multiple improvement tasks that we want to follow up after that. Then let's take a look into the OpenQA project section. So let's see. We have salt pipeline deployment. Okay, sometimes they are not exactly fitting for the project. For example, this one wouldn't exactly fit into OpenQA project, but the point is that we are taking a look at multiple issue trackers in Progress OpenSUSE org. Basically anything which has tools or infra in the subject, or even the things which are not having any tag or label yet, we try it and then decide to which squad it should go, regardless of the project that is in. That means that sometimes tickets stay in not the best fitting project, but ultimately it doesn't matter because we follow up anyway. And then the one usual work that needs to be done is, of course, keeping everything up to date. And as you can imagine, not all the time when you upgrade something, this is without problems. So you can see Leap 15.6, Leap 15.6, Leap 15.6, which was at that time the upgrade target. So this is the stable setup that we run. Leap 15.6, Leap 15.6, and it goes on and on and on. And we have multiple tasks because, for example, we start with OpenQA OpenSUSE org, then we say like, okay, after this is stabilized, in the next step, we do the deployment on the according internal instance. We have CI container images, we have QAM hosts, for example, where the QM dashboard and the template generator reports are hosted. And when we do that, then sometimes we also have problems. So for example, we had a problem with a new version of the Linux kernel at the time because we had many network interfaces, the so-called TUP interfaces for multi-machine tests. And this led to either crashes or then also timeouts together with Wicket and FirewallD. We applied multiple mitigations. Meanwhile, the plan is to shift to Network Manager, which is also an important task for upcoming work for shifting to Leap 16.0, which is based on SUSE SLFO, which supports Network Manager as the main network management framework and not Wicket anymore. But also we shifted to, I think, NF tables based custom firewall definitions and not FirewallD as the wrapper because that was not able to handle that amount of interfaces at the time. It was a bug. I think this was like meanwhile resolved and there's a bug fix, but you know, this can also happen that we report product bugs based on how we run our infrastructure. And I know that this is like comparable to the build service, which also, you know, in the way how they use our products and how they run the infrastructure, they also encounter product issue and then write bug reports and then help to improve our product. Yeah, S390 can be a bit special as well as PowerPC. And in particular, PowerPC is a challenge because how it is expected that we can provide an infrastructure there based on PowerPC is that, well, what we have is, for example, a lot of Power 8 machines, and they are running in the so-called Power NV mode. That means like the non-virtualized, not officially supported way, so that we can run KVM accelerated QEMU tests there. Of course, we also have Power VM and exercise and use that. But with something like SUSE QE 16 also only offering support for Power 10 upwards, that means we will also need to see how we can maintain the infrastructure based on Power 8, which we still need to support the legacy products, which are in maintenance for many years coming. So that also impacts us, and we need to understand like the architecture specifics and the product specific requirements, because it would be easier for us if we say like, okay, now let's shift everything to a newer generation, so run only Power 10 Plus with a consolidated and streamlined infrastructure. That would be easier for us. But of course, there are certain demands where we would still need to run the according specialized infrastructure for testing demands. And then let's take a look into OpenK infrastructure, and that is actually the biggest block. So what we can see, yeah, this is what I mentioned, reliable PowerPC testing setup. This is what we need to provide. And when I say reliable PowerPC testing setup means this broad range of Power NV as well as Power VM on the different generations, both OpenK OpenSUSE org as well as OpenK SUSE DE. Let's see what is other noteworthy things. Yeah, here you can see an example of what I mentioned. So we had two major incidents in the last 2 years concerning OpenK SUSE, where this was mostly under our control. I think there were 2 more incidents where we were, of course, greatly impacted by problems within the SUSE infrastructure, but it basically was like, okay, their central storage provider is down, affecting multiple servers, and that means also the OpenK machine cannot run, but there's nothing we can do about, and actually also because the build service was also impacted greatly at the time, there was actually not so much demand for OpenK because there was nothing to test at the time anyway, mostly. But in some cases, it is under our control, and this is when we run a lessons learned with 5 why analysis, and we did that here, and then came up with multiple ways to improve how we manage our infrastructure. Let's see. We can see a lot of mentions of salt, and that is because we like to maintain our infrastructure mostly with salt. And if anyone is interested, then you can also find the repository upstream for our salt states, and you can see that this is very active. So we just have recently have some updates pushed. This is mirroring what, yeah, this is a mirror of the source code that we use internally. The salt states are published. Those are the generalized recipes, and then internally separated from that is the salt pillars repo. This has having all the machine-specific configuration, credentials, authentications, tokens, and the actual configuration for OpenQA workers, but also all non-OpenQA machines that we as a squad, as QA Infra maintain, they should also be controlled by Salt. And with that, what we do is we run automated nightly patching of the system. We have related to that an automated deployment of OpenQA SUSE QE based on a time-based trigger, but looking at certain states from upstream OpenQA. So for example, OpenQA SUSE QE is deployed if OpenQA OpenSUSE.org shows no problem, if all packages are building fine, if all OpenQA in OpenQA tests are fine, and if the infrastructure itself that we want to deploy on is without problems. Then we automatically deploy, and it's really low maintenance to have that running, and really showing a really high degree of automation and quality that we serve there. There are also separate workshop sessions where I already presented that deployment approach, I think. So yeah, you can see, for example, here, this was one incident. It had minor impact on users and stakeholders, but still, you can see here that this is an urgent ticket with this really strong red here. So OpenQA SUSE showed 502 bad gateway because Nginx and also OpenQA didn't properly start. We quickly could recover that, so that was not that big of a deal. The interesting part is that we use Salt to manage the configuration files, and then the configuration files were corrupted. Like we had a big ini file, and that one was like half written, and then a lot of null bytes included and all that. This motivated us to bring in OpenQA feature. So this is one example of where we see some issues in our infrastructure management, where QA Infra is really focusing on running the infrastructure, not involved with OpenQA development. But there are a lot of pathways where we say like, okay, we can actually improve the software and the products that we run. And one of the main products is OpenQA. So here, what we did is that we said like, okay, having this huge ini file is a problem, not just because of this salt bug, which we reported, but also because it's having problems with maintainability and having it under control. So what we did is for OpenQA switch to having support for drop-in configuration files, so that you would have something like a main configuration file and have multiple little configuration files in a folder following certain usual schemes. Then we also adapted it for the so-called user etc merge approach of OpenSUSE and SLE that was going on at that time. And in the end, what we did is that we switched to not needing the main ini file anywhere at all. That means if you install a fresh OpenQA instance, that you don't have any configuration file and you don't need any, because OpenQA is trying to apply a sane default. And anything that you want to configure, you can create a complete OpenQA ini file, or just drop in files in the openqa.ini.d folder, like a single line of change this perimeter cleanup algorithm, enabling, disabling certain features and such. So ensuring we have a current backup is always good. Too many 500 HTTP responses, so we can see tickets that have something like alert in the tag or mentioning alert in the subject line. And this is like daily operations that we receive some alerts, and we have a rigid procedure to react to alerts to really prevent alert fatigue and make sure that we address the problem. Maybe just a small mitigation. Maybe we can apply some kind of workaround, uh, disable some non-critical services, silence the alert for the time being, solve the real problem carefully, and then bring back the system into full operation. What else? Incomplete config files. Okay, so we had multiple tickets about those, and you know, for an issue like that, sometimes you see an issue for the first time, and then you cannot make heads or tail out of that. And then if it's happening like 3 times, then you really see like, okay, now I get to see the pattern, and then we are on a path to make sure that we can actually proceed. And this is how we identify that this is a problem and solved, but we can also prevent it by restructuring our config file management. Okay, ensure consistent known root password. So if you want to know, I can give you the root password for everything now because we know it. Just kidding. Repurpose PowerPC hardware. Yep. So we have free resources sometimes, and sometimes people order new hardware for dedicated purposes, and then after some time they abandon hardware, and then nobody knows about the hardware anymore, and so then we end up with it. I personally care about making proper use of hardware. So the most important thing is prevent um, that we waste energy and material, yeah, because it happens also that there are machines which are powered on and running, which is actually also an effort for IT, because the engineers managing the data centers physically, they don't know if a machine is used or not. They can just see that a machine is there, it's reserved for certain users, it's powered on, you see the LED lights flashing, so there's network traffic coming in, maybe going out, but actually the machine is not really used. And that's, of course, a point for optimization to prevent something like that, to power off machines, to mark them properly in the inventory management system, to say like the machine is not currently used. This is why we sometimes check with stakeholders and ask like, hey, you have reserved this machine. Do you actually still need it or not? And in the meantime, but this is something upcoming for the next sagas that we will present in some months, is that we also did automated checks comparing the inventory management system, which nowadays is Netbox, against the actual state of machine as we can reach it or how much power it draws. So for example, we check in our inventory management system machines which are marked as unused, and we try to ping them. They should not be pingable because they're marked as unused. They should be off, and raise that as an alert. Also, what we do is we check the power drawn by unused machines. I mean, there can be a little bit of energy that you need to sustain connection to the BMC, like IPMI control, so that you can remotely operate the machines. But machines shouldn't be on and wasting power when they are not used, right? And vice versa. So we also try to do the opposite. So we have some tasks that we want to improve. For example, to say if a machine is actually looks like not being used, maybe the load on the machine is low, then we also cross-check how it is actually marked in the inventory management system. All right, so concluding words for this saga, I would say what we did is we sustained a stable QA infrastructure with the requirements that we have to be able to test all the SUSE products as well as OpenSUSE. We react to issues that we find, and we try to improve, and we came up with improvements during this time period. Overall, I'm really happy with the stability of the infrastructure that we have. I'm also conservative about scaling that. So we could run and support more, but I'm always careful with doing that because from the beginning it looks like we are set up with our highly automated infrastructure management so that we could run more, which then works for some weeks and months, and then suddenly 2 or 3 issues come together at unfortunate times, and then this quickly overwhelms the capacity as a team. So this is why we need to be um, careful when we do such decisions, but again, everything is possible if discussed properly. So any questions or notes from your side regarding this saga? If not, then I can just point out that the next slot on the 20th of March for the workshop is still free. So if you're interested to discuss any topic, bring it up for discussion. Please reach out to me and then we can reserve this time slot for you. Otherwise, guess I will be able to find a spontaneous topic. I have some ideas, but I would like to keep the slot open as an invitation. So with that, thank you guys and goodbye.